You are in the class studying limit. There are many concepts that you can't understand. You took a close look at the textbook and even the internet, but still you don't get it. For these students, we are here to be the solution. As you heard from Mr. Rami, our goal today is to make our classmates experts of limit. Today, among the several subunits of limit, we are going to cover the definition and the basic laws of a limit. First of all, limit is the value that a function or sequence approaches as the input or index approaches some value. Thus, the expression means that the limit of fx as x approaches c is equal to L. The expression is also called the fx approaches or converges to L as x approaches to c. Now let's look at the graph. This graph tells you that when x approaches c, it's approaching f of c, which is L. Now, since we learned the definition of the limit, let's use the definition to verify the following limits. Okay, first, we must be aware of the expressions a and b in order to verify these limits. The formula A states that when limit of constant k as x approaches to c equals k. The formula B states that the limit value of x as x approaches c is equal to c. Now, let's take a look at the practice problems. If you look at this practice problem, it states that limit of 9 as x approaches 5 is 9 because there are no x values that you can input values in. Let's go to the next practice problem. When limit of x as x approaches 1 is 1. This is because when you directly substitute 1 into x, it gives you 1. Okay, now we're moving into a more intense solution. So many students will first think that when they look at this problem, they're like, oh my god, but with our help, you're going to have a spark in your brain and you'll be able to solve this problem. Okay, so in this problem, you're going to directly substitute 4 into x. When you do that, you get this equation. And it gives you 1 minus 8, which is equal to minus 7. Now we believe that you became familiar with the definition of a limit. Then let's move on to our next lesson, the basic limit laws. Basic limit laws are used for computing limits of functions constructed as sums, multiples, products, or quotients of other functions. In all of the basic limit laws, we assume that limit fx and limit gx exist. First, the sum law. The sum of the combined fx and gx by limit can be separated. So, limit of fx plus gx as x approaches c equals limit of fx as x approaches c plus limit of gx as x approaches c. Next, the constant multiple law. For any number k, the constant which is multiplied in the limit can be moved out of the limit. So this is when limit of k multiplied by f of x as x approaches c equals k times limit of f of x as x approaches c. The product law, similar to the sum law, the multiplication of fx and gx in the same limit can be separated as you see. Limit of fx times gx as x approaches c equals limit of fx as x approaches c multiplied by limit of gx as x approaches c. Last but not least is the quotient law. This is the law that most of the students have trouble understanding. If limit gx is not 0, limit of f of x over limit of g of x as x approaches c equals limit of f of x as x approaches c over limit of g of x as x approaches c.
Okay, now the practice exercises using the laws. The limit, to solve the question, limit value of 5t cubed minus t minus 6 as t approaches to 2, sum law, constant multiple law, and product law are required. By using the sum law, the original equation are divided into 3 parts. Limit value of 5t cubed as t approaches to 2 minus limit value of t as t approaches to 2 minus limit value of 6 as t approaches to 2. By using the product law, the limit value of 5t cubed is divided into 3 parts. The limit value of 5 as t approaches to 2 times limit value of t as t approaches to 2 times limit value of t as t approaches to 2 times limit value of t as t approaches to 2. By using the constant multiple law, the 5, which is the constant, is moved out from the limit. After these processes, simple substitution will give you the answer. Limit value of 5 as t approaches to 2 times 2 times 2 times 2, which is 5 times 2 cubed, which equals to 40. To solve the whole question, you have to solve the limit value of t as t approaches to 2, which is 2, as we learned previously. Also, the value of limit 6 as t approaches to 2, which is 6. Finally, the limit value of 5t cubed minus t minus 6 as t approaches to 2 equals 40 minus 2 minus 6, which is 32.